So first of all, logical operators. Logical operators they basically connect two or more relational expressions into one expression. So for instance, if we have this AND operator, so this one with the two ampersands, the way that we would use this, let's say we have the following if statement. Let's say that we have a condition where we need two things to be true for the if statement to be true. So what we can do is, let's say that we want the temperature to be less than 20 and greater than 12 minutes. So we could say, so if temperature is less than 20 and minutes greater than 12. So basically this if statement is only going to be true if both of these statements are true, because we're using this AND operator, and so both statements have to be relational expressions have to be true for that if statement. If the temperature is less than 20 and minutes are greater than 12, if both of those are true, this if statement will be true. If just one of those is false, this if statement will be false. So then we can do something like cout, and we could just tell the user, like, the temperature is in the danger zone. So if the temperature is less than 20 and you're outside for greater than 12 minutes, that's the temp is in the danger zone. We could also put parentheses around both of these relational expressions like this. So sometimes putting parentheses around your relational expressions can make your statement a little more clear, but they're not required. It'll work without them. Another example, the way this needs to be written, it might be tempting to say, let's say that we're looking for a temperature range. So let's say we're trying to see if the temperature is between 0 and 100. So then we could say temperature greater than 0 and temperature less than 100. So this statement will only be true if the temperature is greater than 0 and less than 100. So when you have a statement like this, it might be tempting to say something like temperature greater than 0 and less than 100. So this isn't going to work because the statement doesn't know what it's doing here. So you need to include the temperature in both of your relational comparisons. So this won't work. Don't do that. Another example of that is, let's say the temperature. So let's put our temperature greater than 0, less than 100. This also won't work, so you can't do it like this. Some languages I think you can, but in C++ you can't. So the way that this AND operator is working is it's comparing your two relational expressions. So let's say the temperature's less than 20, so that's true. But then the minutes are only 8, so that's false. So you have a true and a false. That means that this relational expression is going to be false. If we have a false and a true, this will also be false, because they both need to be true. So if we have a false and a false, that will obviously be false. If we have two trues, then this is going to be true. And one thing with this AND operator is, since they both need to be true for this to be true, if our first relational expression is false, the program already knows that your AND statement is false. So it's not going to look at the second relational expression. It's only going to look at the first one, and when it sees that that's false, it's just going to skip the second one and say that it's false. Let's look at this OR. So the one we were looking at was AND. Now let's look at OR. So what the OR operator does is it also compares two relational expressions, and it's true if either of them are true. And this makes sense because it's like this is true or this is true. So if two are true, or sorry, if one of two is true, then this will be true. So the way that we can write this is we could say if temperature is less than 20 or temperature is greater than 100. And this is one line. I just ran out of room. We're going to print C out danger zone. Basically what this is saying is if the temperature is less than 20 or if the temperature is greater than 100, C out C out whatever we want her. You might do some operation or you can do whatever you want here if this is true. And so the way the OR statement works is if they're both true, so then this would be true. If one is true and one is false, so like in this example here, we have if the temperature is less than 20, or if the temperature is greater than 100. If the temperature is 15, that's true. The second part of the statement is false because 15 isn't greater than 100. But since we only need one of them to be true, this is true. And then if the first one is false, but the second one is true, this is true. If they're both false, then it's false. This also does the first relational expression. And if it finds that it's true, it doesn't check the second one for the OR operator because we only need one to be true. So if the first one is true, it doesn't matter what the second one is. What this NOT operator does, so this is called the NOT operator, this reverses the value of an expression. And so in other words, if an expression is true, it will become false. If it's false, it will become true. And so an example of how you would use this is, let's say if, and then we're going to reverse whatever this relational operator finds. So let's just put temperature greater than 100, C out, and then we want to say you're below max temp. So you're below max temp. So what we're doing here is we're saying, so first this temperature is greater than 100 is going to figure out if that's true or false. So if, let's say the temperature is 125, that's going to be true, but then this NOT operator is going to reverse it to false. If the temperature, let's say the temperature is 70, 70 is not greater than 100, so this will be false. The NOT operator will reverse it, so it's true. So basically whatever you find, like whatever this relational operator finds, whether it's true or false, the NOT operator reverses that to the opposite. So now let's talk about order of precedence. So first of all, the NOT operator has highest precedence out of these operators, so highest precedence, and this is followed by the and then the or. So let's say that we have A less than B or Y is equal to Z. So these, well, let's also define this. So this has a left to right associativity. So what that means is that this is going to start here and move to here. So it's going to evaluate the A is less than B first, and then it's going to evaluate the Y is Y equal to Z. So let's look at how this order of precedence would work. Let's say that we have A less than B or Y is equal to Z and M is greater than J. So, and before we look at the order of operation on this, let's, so you could also write this, so you can write this like this without parentheses, but you could also put parentheses around all of these relations. And I actually like to put parentheses because I feel like it's easier to read but you don't need them. It'll work without them. So what's going to happen with this is, and I'm going to put the or here. So the and operator has a higher precedence than the or operator. So this is going to evaluate this first, so the y is equal to z first. It's going to compare it to the m is greater than j second, because the and has a higher precedence than the or. So it's going to be this first, then this, and then whatever it finds with these, whether this is true or false, then it's going to do this or operator. So then it's going to look at is a less than b and determine if that's true or false. So now let's look at something with the not operator. So let's say we have x greater than 2, and we have the not operator. So remember, the not operator is going to reverse whatever that is. So let's say that x is 5. So if x equals 5, well, 5 is greater than 2, so that's true. But then if we reverse this with the not operator, this is going to be false. What if we accidentally, well, maybe we wanted to write it like this, but what if we accidentally wrote this like this? What this is going to do, and this looks really weird, but what it's going to do is this not operator changes, so it takes the true or false and it changes it to the opposite. Since x is equal to 5, remember anything like with the if statements, well, anything other than 0 it's going to consider true. So what it's going to do is change this x equal to 5 to x equals 0, because 0 is false. So if x is equal to 5, it's going to see that as true, and so it's going to change the true to false with the not operator, so now x equals 0. So what's going to happen with this statement is 0 is not greater than 2, so this is going to be false, so then it's going to change it to true. Or sorry, this is going to end up being false. One thing they're really nice for is we can check numeric ranges, so we can check to see if a value falls within a certain range. So we've already looked at that somewhat with the temperature. So like right here we said temperature greater than 0 and temperature less than 100. So any temperature between 0 and 100 will be true in that statement. We could also use it to check, say, a grade range. So let's say that you have a program where you're asking the user for a grade, and the only valid grades are between 0 and 100. If the user enters something outside of that range, we can flag that, and we're going to see how to check user data later, but we can flag that and then tell the user they entered the wrong data. But the way we can do that is, let's say if grade is greater than or equal to 0 and grade less than or equal to 100. So this is going to be true if the grade falls somewhere between 0 and 100. So this is the kind of statement you would want to use if you were, say, asking the user to input a grade and you wanted to make sure they didn't enter a negative number or something greater than 100. So then we could do cout valid grade. We could also check it like this. So we could say if grade is less than or equal to 0 or grade greater than or equal to 100. So this is saying if the grade is less than 0 or if it's greater than 100, we know that they entered an invalid grade, so then we could cout invalid grade. So either of these would be a good way to check to see if they entered a valid input.